Hello and welcome to Module 9 in our Python series. Our discussion today is going to focus on the date and time modules, and we'll use what we learned to build our own clock. Before we look at the library itself, we need to remember a few things. One is that not all functions in the time module specifically are available across platforms, which means that some of the functions would be available only on the Unix platform. The semantics of these functions, meaning the way the code is interpreted, could vary across platforms. Epoch is the point where time starts, and on Unix, the epoch is 1st Jan 1970, that's 70. Windows 10 also has the epoch as 1st January 1970, as we will see shortly. But having said that, there is a method that we can use to determine the epoch of a specific platform, and we'll take a look at that when we go to the Python shell. The time module may not be able to handle dates and times before this platform specific epoch or far into the future, the current cutoff point being 2038. And this cutoff point is determined based on the C library. Why the C library? Because the functions in this module call the functions from the C library directly. Now coming to the datetime library, the first two items you see on your screen, those are constants, and in C as well as in many other languages, when you're defining constants, they're always defined in all caps. Remember, a constant in code represents a value that is never going to change throughout your code. And instead of using that value, we use the name to indicate the value that the constant represents. That makes for easier readability of code. So we look at these two constants, and then we look at the date method, the today method, weekday and ISO weekday. What's the difference? Weekday follows the Gregorian calendar, that's the normal calendar that we follow. The ISO weekday, on the other hand, follows the ISO calendar. Now, when we ask what is the ISO calendar, the answer is that the ISO calendar is the one that always begins on the Monday nearest to January 1st of the Gregorian calendar, right? Which means that the ISO calendar could begin before the Gregorian calendar ends. Case in point is Monday 30th December 2019, which was towards the end of the Gregorian calendar, or rather before the Gregorian calendar ended, was actually the first day of the ISO calendar for 2020. Now the ISO calendar is issued by the Geneva-based International Organization for Standardization and is used by governments and businesses for calculating financial dates as well as for a standard representation of dates and times. Remember that we could have a date like this, which, if you look at it from the DDMMYY, that is day, month, year format, could read as 11th April. But if you look at it from the month, day, year format, which some countries follow, then it would read as 4th November, right? So to take away this ambiguity, ISO came out with their own format where the year is represented by the entire number 2021, 11 is the month, and 4 is the day. So this takes away the ambiguity of whether we're talking about day, month, year, or month, day, and year. Now coming to the time delta object, we will look at this later, right? Because this is an object that is created or returned as a result of an operation that we perform. So we'll see that later. Now let's go to our Python shell and first see how we can determine the epoch for a particular platform. So here we need to first import time and then type in time.gm time, pass in the value 0. Now you can see we've used the time module here. So that's the module. This is the class, right? And of course, we have the epoch for this platform, which is Windows 10. And you can see that the year is 1970. The month is January. The day is 1. It's 1st Jan 1970. Now moving on to min year and max year. So to do that, we need to import the date time module. And then we can just type in date time dot min year and gives us the value 1. So that's the lowest value we can use to represent the year. And then we can look at date time dot max year, and that value is 9999. So this is the maximum value that we can have for the year. Anything larger than that will give us an error. Now let's look at the date method. We'll use a variable for this, dt equal to date time dot date, and the date method here needs some parameters: the year, the month, and the day. But we cannot use a 0 there, or Python will give us a syntax error. So we need to cut off that 0 and just put in the 4. And now if you look at the type of object that dt is, you will see that it is an object from the class datetime.date. Remember, an object is an instance of the class. Once we have that object created, we can access the property. So dt.year will yield 2021, dt.month will return 11, and dt.day will return 4. Now once we have that object, we can have the date in certain formats. So dt.iso format will yield the date in numbers like that, right? Year, month, and day. And you can see ISO format has the year in full, right? You could also use the weekday method on this object, date.weekday, and you see that yields a number which is 3. What does that mean? 3 represents Thursday, 0 representing Monday. As far as weekday method is concerned, use the ISO weekday method and you'll get a different number. So that yields 4. So here Thursday is represented by the number 4, with Monday represented by 1, and of course Sunday is 7, whereas Sunday here would be 6. Okay, so that's the difference between these two. Using this date object, we could also use a function or a method on it called ctime. And you can see we get the date in a different format, right? But of course the time is not represented correctly, and that's because we haven't passed it in here. We haven't passed in hour, minute, and seconds. But having said that, the date method does not allow more than 3 parameters. So if we try to pass in more than 3, we'll get an error. So let's try to pass in the time here, 8:29, and the message says function takes at most 3 arguments, right? So we need to use another method, which is a date time method. So here we can see let's use a different variable, cdt equal to date time. It's the same module, dot date time. The method is different. And now we can pass in the year, the month, the day, the hour, the minutes, and we could also pass in the seconds. So let's pass in here 51. And now if you look at CDT, you can see we have all those values. Use a ctime method now on this variable, and that's what you get. Okay, but having said that, or having done that, there is still another method we can use. We look at that later. Now, of course, with CDT, that is a variable we created using the datetime method, we can access the other properties as well. So cdt.year, cdt.month, cdt.day. But we can also access the hour. So cdt.hour, cdt.minute, and cdt.second. Right, so you can use these properties in your code. If cdt.day equal to something, then do something, right? Okay, moving on. We've looked at min year, max year, we've looked at date. We need to now look at today, right? So we saw how with the date method, we need to pass in these parameters. With the today method, it does not need any parameters. So now I'm going to clear the screen first. I hope you remember lambda, right? Okay, so now looking at how to use the today method, we can say today equal to date time dot date dot today. That's how we need to access this particular method, right? And then you will see that today has got the current year, the month, and the day. And so we can access those properties directly. We can just say today dot year, and note that we did not pass in any parameters. So this is a more convenient way of getting the current date, right? Now, sorry, I just put in the wrong thing there. It should have been today.d. Therefore, we got this error. Now, instead of doing something like this, if you don't want to do this, you would have to say from date time import date. And then you would just say date dot today. If I do it directly though, you will see that I get an error. Right, so I'd have to say from date time import date and then do this, then you will not get an error. And now if you say date dot today, you can store that in a variable td equal to, and you can see that we get the same result. Right, so that's two different methods of achieving the same thing. So now we've looked at the today method as well. And of course, with the today method, you can use weekday or ISO weekday. You will get the same results, right? So I hope that's clear. If we use ctime again, we will get the time as 00, right? Because it's not really available here as parameters. Right. Now, what if we had the date in one variable like this, and we had the time in another one, and we wanted to combine the two. So there is a combine method that we can use. For that, of course, we need to access the time and put it into a variable. And this is not using the time module. T equal to date time dot time and pass in the current time 8:37. So class that you can see here is datetime dot time, meaning it comes from the datetime module and it's the time class. Now that we have that, we can use the combine method. Now the combine method comes from the datetime class in the datetime module. So we can say from datetime import datetime, and then we can say combined equal to datetime dot combine, and we pass in the date and the time, right? And now if we use a ctime method on this variable, you can see we get it with the time, right? Just as we did when we passed in all the parameters including the time. So this is another method of achieving the same result. Now moving on to the time delta object. To understand the time delta object, let's do these two simple exercises. Find the number of days left until New Year's Day 2022. So how do we do that? So what we do here is we will first have a variable called New Year. So New Year equal to date. We've got the variable today dot year, comma, month, comma, day. Okay, once we have that, then we can say days until New Year, 1 years equal to absolute method. I hope you remember this. Today minus New Year. So here we are subtracting two dates, right? And if you look at the type of days until New Year's, you will see that's a time delta object. Now if we look at days until New Year's, so let's just take away these brackets so we don't have to type that in again. You can see we have days equal to 57. How do we access that? We just say days until New Year's dot days. Okay. Now let's do the next exercise so that you have a better understanding. Find the number of days until your next birthday. So now going back to the shell. First of all, my birthday. Let's keep that as a variable equal to. Now here we'll say date of today dot year, comma, the month when your birthday is, let's say 12, or rather Let's take something in the past. So 9, 25. Now we'll check if my birthday, we need to check if the birthday is past, which is true in this case, less than today, then we'll say my birthday dot replace. We need to now say that the year should be the next year, right? So year equal to today dot year plus 1. Does that make sense? Since my birthday is already in the past, right? So it's less than today, then replace the year in my birthday with year plus 1. There's some mistake. So my birthday, and then you can use the up arrows and down arrows to go to the previous commands, right? If my birthday less than today, then we have my birthday dot replace, and this should be a plus sign there. There was a mistake. And that gives us 2022, right? September 25th. Then we can say time to next birthday equal to ABS of my birthday minus today. Now if you look at the type of object that time to next birthday is, you will again see that's a time delta object. And if you look at the contents of time to next birthday, you see the days. So now you know how you can access those days. You will just say time to next birthday dot days. I hope you understood time delta. Moving forward, we need to now move on to the time module. We've already looked at hour, minute and second, but we need to look at the time method itself. But I'm going to start with the now method, which comes from the date time module. Let's say now equal to date time dot now. So you'll see now again this is a date time object, but I have the year, the month, the day, the time is the 24-hour clock. So hour, minutes, seconds and microseconds. We can also use a time method. We can say time obj, I'm using a variable, equal to now dot time. And if we look at the contents of time obj, you will see that it's returned to us just the time. So you see the difference here. Here we are using the now method and getting the entire year, month, day, etc. But here we get just the time. And of course you can say now dot year, now dot day, and so on until now dot microsecond. And with time obj, We can access hour, and then of course minute, second and microsecond. Right? Now moving on from this, we've seen all of these. We need to now look at GM time, local time and strip time. We'll come to these attributes later. Let's first go and use GM time. I'm going to clear the screen now. So we use GM time passing in the value 0 to find the epoch, right? But we can use GM time with no parameters. So first of all, we need to import time. Remember, we need to import time again because we had imported date time, so that command overrode the import time command. Okay, so now import time, and we can say time.gm time. Here we are not passing in any values. And you can see this gives us the year, the month, the day, right? And you can see that's the current date and the current time. But this is GM or Greenwich Mean Time, right? So I'm in the time zone which is GMT plus 4, right? So therefore this is 16 plus 4, right? So that would be 20. I hope you got that. So that's how GM time works. Now if you look at the contents of TM year, so I could save this in a variable. Let's say current time equal to, and then I could access those properties, right? Current time dot TM year, and so on and so forth. Now keep in mind that these particular properties or attributes where you have W day, note how this is 3, right? So this is using the Gregorian calendar, so the weekday method in effect. The year day is 308. This is to do with daylight saving time, and the values could be 0, 1 or -1. So if we look at the slide here, this shows you all the valid values for these attributes. Year, the month would be between 1 and 12, the day of the month between 1 and 31, the hour, the minutes, the seconds, and then daylight saving time 0 would mean that it's not available, 1 is it's available, and -1 means it's unknown. Okay, now we could use local time as well. So we could say local time is equal to time dot local time. And then if we look at local time or log time, you can see that this is now again the same date, but it is the current time, right? Now once I have that current time, I can use a function called ASCII time. So I can have the date shown to me with the current time. Remember I spoke about this earlier when we use the C time method, right? But with this I can get the current time. How do I do that? I can just use a variable ASC equal to time dot ASC time of local time. And then if you look at the value, you can see that this is Thursday, November 4th, and I have the current time. Also, if you look at the type of object that ASC is, you can see that that's a string. If you look at the type of log time, You can see that this is coming from the class struct time, which is from the module time. Right? And similarly, current time would have the same type as log time. Now, if we say time dot time, use a time method there, we will get the time in seconds since the epoch. That's a huge number, right? And you can also get the time in nanoseconds by saying time dot time underscore ns, and that's another huge number. Time dot min. Now you can see here I have an error. Why? Because this particular attribute is available only in the date time module, not in this time module. So we've got to say from date time import time, and then we can use that attribute, and this gives us the earliest representable time. Try time.max, and that will give us the latest representable time. So I hope all this is clear to you. Now coming to strip time and strf time. And strf time, as is mentioned here, converts an object to a string according to a given format. There are different directives we can use for this format, which we'll see in the next slide. Strip time, of course, is used to parse a string into a date time object. What we need to pass to strip time is a date string and the format. But coming to the directives we can use for strf time, here they are. Right, we'll use some of them now. You can try the rest after this session. So let's see, we have today, right? Today.strf time, and let's say we want %a, comma %d, and then we want a dot, then we want %b and %y. What does this yield? Okay, it's a mistake here because I didn't close the quote. So you can see here we have Thursday, 4th November 2021. Right, remember that %a gives us the full day, %b gives us a full month, and then you have %y, which gives us the year in full. So you can try out these different directives. So now we've looked at strf time, we need to look at strip time. From date time import date time. Okay, and here we'll say strip date equal to date time dot strip time. We put in some date. Let's put in the time as well, and then put in a format, %d stroke %m stroke %y, right, and then for the time %h colon %m. And now if you look at strip date, you can see we have the date time object. So that's how strip time is used. Now that we've done this, we can proceed to create our own clock. So these are the formats as well. Now to our mini project where we're going to create our own clock using VS Code, Python and tkinter. So now we need to go to command prompt. But I suggest you run it as administrator, because sometimes when creating the directory, you may get the message access denied. We are in the system folder. We need to get out of there. So cd /. We look at the directory. This is what we see. Change directory to users. And you will see Python scripts. Change directory to Python scripts. And now we can make a directory and call it the clock. Change directory to the clock and code space dot. Okay, so now we are here. We need to start a new file. You may get a message, do you trust the author? Just agree to that and then start by creating a new file. We're going to call it clk.py. And you start with our function. Let's call it def our clock, right? And since we're using tkinter, we'll have wn for the main window or the root window equal to tk.tk, create an instance of the tk class, and then we'll have geometry set. So wn.geometry equal to 300 by 300. You can change this if you like. Right, so you can change those dimensions. Then we have a label equal to tk.label. And here we're going to have the text equal to the clock. And we can use other attributes like foreground. Let's put the foreground color as yellow. And then the background color bg equal to, and let's have this as purple. Again, you can change these colors. Hope everything's clear so far. Earlier we had used the grid method, but now we use the pack method. So label.pack, and with the pack method we can specify where we want this label placed. We can use the side attribute and say side equal to top. You can also say side equal to left, right, or bottom. Now you can see that Python is telling us that top is not defined. We need to say here tk.top. Now of course it says tk not defined. That will be cleared once we import tkinter. Right, so let's leave that. Once that is done, we want another label. So label, let's call it that, equal to tk.label, and then text, we keep this as null. We'll have a height equal to 4 and width equal to 8. So this is the second label that we have here for the window. And again we use the pack method. So label.pack, but this one we will not specify where we want it. And now we need to call a method to keep updating the clock. Remember, the clock has to change time, right? And normally the clock changes time every second, right? So we call a function, let's call it change time, right? And then of course we have our main loop. That's all. So I hope this is clear. We have WM, which is our root window. We have the geometry set. We have two labels. And we're using the pack method. First label we want it at the top. The second one we're not specifying where we want it. Remember, the text for the second label is also none or null. And then we have the main loop. Main loop is required in order to reflect changes that would happen in the window. And now let's go ahead and define our next function, which is change time. And here we see that's our variable now equal to time dot strf time. We want the format %h colon %m colon %s, hours, minutes and seconds, right? And then we use the configure method to change the text in the label. So label dot configure, and we'll remember we're changing the text only in one label, this one where the text is null. Text equal to now. Okay. Now remember, the time has to change every second. So how do we do that? We just say WM, and we're using the after method here. After 1000 milliseconds, we want to call the same method again. So this is what is called a callback method. After 1000 milliseconds, call change time back again. And that's all. And now we'll say import tkinter as tk, right? And now you can see that squiggly has disappeared. And we'll also have to import time. We still have squigglies under WM and label. Why is that? Remember, we are accessing them in this function, but they are declared here. And so we need to mention them as global. So global WM, comma, label. Right? All squigglies gone. Let's run this now and see what happens. Okay, so run. Not seeing the window. Did anybody figure out what was wrong? We didn't call our main function. So here we will say our clock. Right? Now let's run that. Spin the terminal. Run it again. And there you have the clock. Right, so this ends our session for today. In the next session, we'll be looking at the calendar module and we'll do a simple to-do application. So till then, take care, stay safe. Bye.